Let's solve a numerical on a circuit which has a resistor and capacitor connected in series across an AC supply. Okay, so the circuit is given like this. We have a resistor of 100 ohms and a capacitor of 100 microfarads which are connected in series across an AC source of voltage Vs is equal to 230 at an angle of 30 degrees. The same is given in rectangular form also. So one suggestion is that whenever you calculate any parameter in AC circuits, it is better to write the answers both in rectangular form and polar form. Okay, so let's start with the solution. So the question is like this, or the numerical is like this. So they have given the circuit and they are asking us to calculate the impedance, main current, and the current flowing through each component, voltage across each component, power factor, and the three powers: active power, reactive power, and apparent power. Okay, so first we know that whenever we want to calculate impedance, we should know the values of resistance and reactances. So as we have only capacitor connected in series with a resistor, we have to first calculate the value of capacitive reactance. The given capacitor value is C is equal to 100 microfarads. So XC, to calculate XC, I should use the formula 1 by 2 pi FC. So if in the question or in the details of the numerical, if there is no mention of frequency, then you can take 50 Hertz as the frequency, because in India, as per Indian standards, the AC supply has a frequency of 50 Hertz. Sometimes they mention the frequency also in the problem, then you have to consider that particular frequency. So here I'll be considering F, I'll take F as 50 Hertz, because in the circuit or in the data what they have mentioned, they have not given the value for frequency. So if I do the calculation, 1 by 2 pi into 50 into 100 into 10 to the power of minus 6. Most of the students, what they do is they'll take only this 100. It is 100 microfarads. So you should take that micro into account as well when you are doing the calculation. So XC is equal to 31.83 ohms. XC is nothing but capacitive reactance of the circuit. Okay, so let's start with the solution. So first one is impedance. So whenever you want to calculate the impedance of the circuit, so Z is given by R plus minus JXC. When we have a capacitor connected in series with a resistor, I have to make sure that I use a negative sign attached with the J operator. So this can also be simply written as R minus JXC. So this is the standard form of impedance representation for RC series circuit. So impedance of this circuit will be R is given as 100 minus J 31.83. So Z is given as 100 minus J 31.83 ohms. So this is in rectangular form. In polar form, it is given as 104.9 at an angle of minus 17.65 degrees. Again the unit will be ohms. Okay, so the impedance of the circuit is as shown. Next, we are supposed to calculate main current, which is I. So from Ohm's law, similar to the previous problem, we know that Vs is equal to I into Z. For series circuits, in AC circuits, instead of only resistor, we are using impedance. So I is equal to Vs by Z. So Vs is given as 230 at an angle of 30 degree, divided by Z is given as 104.9 at an angle of minus 17.65 degrees. So if I calculate this using a calculator, I'll get the value as 2.19 at an angle of 47.65 degrees amps. If I write this in rectangular form, the value will be 1.47 plus J 1.61 at an angle of 1.61 amps. So this is the value of main current. Next we have to calculate the current flowing through each component. Okay, so we have a resistor, so we will have current IR. We have a capacitor, so we will have current IC. So as shown in the circuit, when both the components are connected in series, we know that current flowing through IR will be equal to IC, and that will be equal to main current I. So the current flowing through all the components will be same. So 2.19 at an angle of 47.65 degrees in amps. Okay, the same thing can be written in rectangular form as well. So the second part, main current and the current flowing through each component, we have calculated. Next, we are supposed to find out the voltage across each component. Third part, voltage across each component. So we have a resistor and a capacitor connected in series. So we have to find out VR and VC. So VR is given by IR into R, but IR is equal to I, so I into R. So I is equal to 2.19 at an angle of 47.65 degrees into the resistance value 100. So the voltage across resistor will be 219 at an angle of 47.65 degrees, and the unit will be volts. If I write this in rectangular form, it will be 147.53 plus J 161.85. So as I told before, it is better to write all the answers in both rectangular form as well as polar form. Next we have to find out the voltage across the capacitor. Here you should be a bit careful. So VC is given by IC into minus JXC. So whenever you have a capacitor, And whenever you are calculating the current flowing through a capacitor, you should have a negative sign next to the J term. Okay, if you had a inductor, it was supposed to be plus J operator. Here it is minus J operator. So IC is not, so IC is equal to I, therefore I into minus JXC. So I is given by 2.19 at an angle of 47.65 degrees into minus J, the XC value which we calculated was 31.83. If I do the multiplication, I will get the value as 69.70 at an angle of minus 42.35 degree, and this is in polar form, volts. If I write the same answer in rectangular form, it will be 51.51 minus J 46.95 volts. So VC in polar form and VC in rectangular form. So next let's find out the power factor. So power factor is the cosine of the phase angle, cos phi. This can be calculated using the formula R by Z. So the resistance of the given circuit is 100, and we know that the impedance in polar form is given by 104.9 at an angle of minus 17.65 degrees. So this is the magnitude of the impedance. So here I have to substitute 104.9, which gives me 0.95. So this is the power factor. Next we have to calculate the different powers. So fifth one is powers. So there are three powers, P, Q and S. So P is the real power. So P is given by P is equal to magnitude of Vs into magnitude of I into cos phi. So magnitude of Vs, the supply voltage is 230 into the current magnitude from the calculation is 2.19. So 2.19 into cos phi is 0.95. So the answer will be 478 watts. So watts is the unit for real power. Okay. Second one, Q, which is the reactive power. So Q is equal to again Vs into I into sin phi. So Vs is given as 230 into 2.19 into sin phi will be 0.3. So Q will be 151 volt ampere reactive. This is the unit for reactive power. Next we have to find out S. S is the apparent power. So S is equal to magnitude of Vs into magnitude of I. So S is equal Vs is equal to 230 into I is equal to 2.19, which gives me 503.7 volt amperes. This is the unit for apparent power for S. So these are the three powers: real power, reactive power and apparent power, which you are supposed to calculate.